Hi everyone and welcome. I am excited to let our team of AI avatars walk you through the model that my dad built. I hope you find it useful. Enjoy.
Thank you, Thomas, and welcome to the new era, the era of artificial intelligence and its application in the game of football. In this video, the team of our AI avatars, such as myself, will explain how to interpret the statistics and plots presented in the videos of this channel, how you can use it to understand the game of football, how to make predictions about the upcoming games, and how to have fun doing it. We will use an example simulation between Manchester United and Arsenal, which takes place on March 9th, 2025 as part of the Premier League regular season. Relax, kick back, and enjoy.
Now, what you see in front of you is an output of suite of models built using AI or artificial intelligence and machine learning. So, what is AI really? Imagine you're a football analyst and you want to predict the outcome of the next match. You have a lot of data about the teams, like past performances, player stats, and team strategies. So AI is like having a super smart assistant. This assistant can analyze all the data you have and make predictions about the match. For example, it can look at how a particular team has played against similar opponents in the past and predict whether it is likely to win or lose the next game. Machine learning is a special skill that your assistant coach has. Every time a match is played, the assistant learns from what happened. It looks at what strategies worked and what didn't, and it uses this information to make better predictions in the future. So, the more matches your team plays, the smarter your assistant coach gets, and the more accurate its predictions become.
In our case, we are running 1,000 simulations, as you can see from here. Each simulation is a combination of several statistics. First, the expected stats. These are modeled basic statistics for each team, such as total shots, shots on goal and shots off goal, shots inside the box and shots outside the box, percent possession, total passes, passes accuracy, goalkeeper saves, corner kicks, offsides, total fouls won, total fouls conceded, yellow cards, and red cards. On both sides of this box, you can see the actual value for each statistic that each team is expected to show in the game. During simulation, the values are fluctuating because the model is converging, and the more simulations we run, the closer the value shown is going to be to the actual expected value. Also, you can see the bars, light blue and dark blue representing the balance for each statistic for each team. This is a helpful visual aid to help you visualize the balance of power in the upcoming game.
Now let's move outside of the box. Let's look at the SV and P of SV values. What are those? SV stands for simulated value, which means for each iteration the model simulates the most likely value for each statistic. For example, let's pause here. At simulation number 118, or 882 since we are counting down from 1000, the simulated value for total shots is 5 for Manchester United and 11 for Arsenal. Now, this value is not random at all, although it is simulated. It comes from a specific distribution of expected simulated values. This distribution is modeled based on past performance of this particular team against that particular opponent. And if there is no history of the two playing against each other, then the model selects the team the closest in style and performance. An AI model takes into account many different factors to assign this particular value. Now, like in any model, each value should have an associated probability to go with it. This is where the P of SV comes in. This probability shows the likelihood of this particular simulated value. Going back to our example, the probability that Manchester United will have at least 5 shots is 93%, and the probability that Arsenal will have 11 or more shots is 67%. The same applies to all other expected stats.
Now, to ensure that the generated values maintain historical correlations, that is to say that if we simulate an increase in the total shots taken, then the simulated value for the shots on target would also likely increase. A technique used in finance to simulate returns of correlated assets called Cholesky decomposition is used here to simulate correlated statistics. It is a necessary mathematical requirement to make sure simulated values actually make sense. Okay, now let's move to the top of the screen and talk about those 3D graphs. Each new point of the simulation for both teams is represented by a popping white ball like here. The plot rotates, so you can visualize the simulation of each statistic relative to another statistic and the winning probability. Every iteration has a winning probability axis in the plot. The same statistics are shown for both teams, so you can actually see how different they are, not only relative to another statistic, but also to each other. Take a look at these 3 examples. Arsenal seems to have more shots inside the box, but not all of those shots will be on target. Also, for a low possession game, the number of offsides is likely to be higher for Arsenal than for United. Finally, the Arsenal is expected to have more corner kicks than United, while also maintaining their discipline.
Now, there are a few things to mention before we move to probability plot. Formation. These formation numbers are taken from the past 20 games. Suppose the team had formations 4-4-2 and 4-3-3 in the past 20 games, the model will choose the formation randomly out of these 2 options. If you see that the formation is not updating, this means that based on the data, the formation in the past 20 games was steady. Now let's move on to the XGs, the expected goals.
The XG model is a multi-layer neural net that takes as input 6 seasons of league data, meaning every single match in our case, top 5 leagues plus Saudi and MLS, over past 6 years thanks to the data from API Football. So, what is neural net? A neural network is a computational model inspired by how biological brains work. It has layers of interconnected nodes called neurons, which process and transmit information. The connections between neurons have weights that adjust as the network learns from data. In a neural network, the first layer is the input layer that receives the data. Then, there are hidden layers that process the inputs and pass the information to the next layer. The final layer is the output layer, which produces the network's output. The network learns through a process called backpropagation. In this process, the network makes predictions, calculates the error in these predictions, and then adjusts the weights of the connections to reduce the error. This process is called deep learning, and this learning process is repeated multiple times on the training data. This type of model was used to predict the XGs.
Having said that, a similar model is used to get the graphs shown in the top left, starting from the top. This one shows how the winning probability for the home team converges during the simulation. After each iteration, an average of simulated probabilities is taken, and that value is tallied into what looks like a bar plot. The average value is also shown below, and as the number of simulations increases, that value converges to what is going to be our final predicted winning probability. The graph below shows the convergence of the game tying probability, and the one below the winning probability of the visiting team.
Take a look at the curves fitted to each graph. The white curve represents the Gaussian, or normal fit, while the turquoise one shows the gamma fit. Now here's the important part. The Gaussian fit works best when the data isn't skewed, meaning the probabilities are fairly balanced on both tails. On the other hand, the gamma fit outperforms when there's skewness in the data. It's great at capturing those asymmetries. After running a large number of simulations, our predictions begin to form a specific shape. This shape can be described by its dispersion and skewness. By fitting analytical curves to this shape, we gain deeper insights into how our predictions behave. And here's where p-values come in. They help us evaluate which distribution, Gaussian or gamma, best captures the data. A higher p-value means our data aligns more closely with that particular distribution. In our case, the p-values are close to 0, reflecting the complexities in our data. While this doesn't affect the average of the predicted probabilities, which remains solid, it does make deviations from the average less transparent.
Now a few things to note before we conclude. The values shown in red for win probabilities and XGs are just the values based on each individual scenario. For example, if we pause it right here, based on this set of simulated values, the probability of Manchester winning will be 44%, match tie will be 34%, and Arsenal winning would be 23%. Same applies to the XGs. Under these scenarios, the expected goals for Manchester is 2.025 and for Arsenal is 2.183. But remember that the more simulations we run, the more reliable the actual predictions will be. So, the red numbers are good to understand specific scenarios and the likelihood of each scenario by pausing the video, but should always be used with caution, understanding the fact that this is just one scenario, and the more scenarios you look at, the better.
Another fun thing you can do by pausing the video is to test your luck for picking the game outcome. In the bottom left corner, the 3 possible game outcomes pop up based on the probabilities assigned by the model. In other words, if, based on the model, game tying probability is 30%, then by the end of the video, Thomas's tie will appear 300 times, given that we run 1,000 simulations.
Finally, both head-to-head stats and the individual team's performance over the last 10 games are shown on top of the screen right here. And each team's leaders as of the match day, and based on all clubs' competitions this season, are also shown for the following stats: goals, total shots, shots on goal, assists, total passes, key passes, total duels, won duels, attempted dribbles, successful dribbles, tackles, blocks, interceptions, goalkeeper saves, fouls drawn, and fouls committed, yellow and red cards. And finally, don't forget and show full support for the youngest player in each team. We hope you found this instructional video helpful. We are posting simulations for most of the major matches weekly. Thank you for watching. Goodbye.